In this video, we're going to look at another example of an improper integral. Here we have integral from minus infinity to infinity 1 over 1 plus x squared dx. So basically, you can see that the integrand is symmetric with respect to the y-axis. It is in fact an even function. So it is logical to split it into two separate integrals, into the sum of two separate integrals from minus infinity to 0 and then from 0 to infinity. So let's do that. So the integral from minus infinity to infinity 1 over 1 plus x squared dx, we write this as integral from minus infinity to 0, 1 over 1 plus x squared dx, plus integral from 0 to infinity 1 over 1 plus x squared dx. So let's apply improper integrals. Rewrite this as limit t goes to minus infinity from t to 0, 1 over 1 plus x squared dx, plus limit t goes to infinity, 0 to t, 1 over 1 plus x squared dx. So the basic idea is this. When you have a limit that's infinity or minus infinity, replace that by a variable. In this case, we decided to choose t, but you can use any variable. Then take the limit as t goes to, say, minus infinity in this case. And here we have infinity, so replace the upper limit by t, and then take the limit as t goes to infinity. That's the basic idea of improper integrals. All right, so this integrand, y is equal to 1 over 1 plus x squared, is an even function, is symmetric with respect to the y-axis, That means f of minus x is equal to f of x. So we can rewrite the integral from minus infinity to infinity 1 over 1 plus x squared dx as 2 times the integral from 0 to infinity 1 over 1 plus x squared dx, which can be written as 2 times the limit as t goes to infinity, and replace the upper limit, which is infinity, replace it by t. 0 to t, 1 over 1 plus x squared dx. All right, so what we have is the integral from minus infinity to infinity 1 over 1 plus x squared dx. That's equal to 2 times the integral from 0 to infinity 1 over 1 plus x squared dx. And then we take the limit as t goes to infinity, integral from 0 to t 1 over 1 plus x squared dx. Now, what is the antiderivative of 1 over 1 plus x squared? Well, that is tan minus 1x, because the derivative of tan minus 1x is 1 over 1 plus x squared. So that's going to give us 2 times limit t goes to infinity tan minus 1x evaluated from 0 to t. So now we just apply the fundamental theorem of calculus, and what we get is 2 times limit as t goes to infinity tan minus 1t minus tan minus 1 of 0. What is tan minus 1 of 0? Well, tan minus 1 of 0 is just 0. And what is tan minus 1 of infinity? What is the angle whose tangent is infinity? Clearly, you can see that's going to be pi over 2. So what we get is 2 times, let me change colors, 2 times pi over 2 minus 0. That gives us pi. So that's basically the area under the curve. So you can see how this area, let's shade that in green, this area is pi. All right, so let's look at another question. Actually, let's rewrite this as integral from minus infinity to infinity 1 over 1 plus x squared dx. That's equal to pi. All right, here we have integral from 0 to infinity, another question, sine squared x dx. We're going to need to apply trig identity. Sine squared x is 1/2 times 1 minus cosine 2x. So what we have is integral from 0 to infinity 1 half times 1 minus cosine 2x dx. Now 1 half is a constant, passes right through the integral, so we get 1 half limit as t goes to infinity, integral from 0 to t, 1 minus cosine 2x dx. All right, so what we have is integral from 0 to infinity sine squared x dx is equal to 1 half limit t goes to infinity, 0 to t, let's fix that. The upper limit is t, and 1 minus cosine 2x dx. So let's carry out the integration. We have 1 half limit as t goes to infinity. And what is antiderivative of 1? Well, antiderivative of 1 is just x, because derivative of x is 1. What is the integral of cosine 2x? That's going to be sine 2x divided by 2. We divide by 2 because we're reversing the chain rule. And we apply the fundamental theorem of calculus from 0 to t. That's going to give us 1 half limit t goes to infinity. And put the upper limit in, we get t minus sine 2t divided by 2 minus, put 0 in, we get 0 minus sine 0 divided by 2. Sine of 0 is just 0. So now what do we get? We get 1 half limit t goes to infinity, t minus sine 2t divided by 2. Now, sine 2t is always going to be between 1 and negative 1. If you divide by 2, sine 2t divided by 2 will be between 1 half and negative 1 half. So we can say that t minus sine 2t divided by 2 is going to be less than or equal to t plus 1 half, larger or equal to t minus 1 half. And that's because this part here, sine 2t over 2, we show that that's between 1 half and negative 1 half. Now let's apply the squeeze law. Limit t goes to infinity, limit t goes to infinity, limit t goes to infinity. This is going to give us infinity. This gives us infinity. So by squeeze law, this whole thing, the limit as t goes to infinity of t minus sine 2t divided by 2 will give us infinity. So the answer is 1 half limit as t goes to infinity, t minus sine 2t divided by 2. This is infinity. That means the integral diverges. So the answer to this integral is infinity. Diverges. All right, let's look at another question. Here we have integral from 1 to infinity 1 over x squared plus x dx. We're going to apply partial fraction decomposition. 1 over x squared plus x can be written as 1 over x times x plus 1. That's equal to a over x plus b over x plus 1. If we apply partial fraction decomposition, b can be found to be a is 1 over x, and b is negative 1 minus 1 over x plus 1. That's very easy to do, and we've already done a module on partial fractions, so you can easily do that at home. Integral from 1 to infinity, 1 over x squared plus x dx. That's equal to limit as t goes to infinity, integral from 1 to t, 1 over x squared plus x dx. And that's going to be equal to limit t goes to infinity, integral from 1 to t. And we have applied the partial fractions. We get 1 over x minus 1 over x plus 1. That is the integrand after we apply the decomposition. Now we get limit t goes to infinity. And what is antiderivative of 1 over x? Well, that's just going to be log of absolute value of x. Minus, what is antiderivative of 1 over x plus 1? That's log of absolute value of x plus 1. Evaluated from 1 to t. That's equal to limit t goes to infinity. We're going to apply the log rules. The log of log x minus log y is log of x over y. So we're going to get log of x divided by x plus 1. Evaluated from 1 to t. That's going to give us limit t goes to infinity, log of t over t plus 1, applying the fundamental theorem of calculus, putting the upper limit in, minus log of 1 over 2. Now, we know that t is bigger than 1, and log of, that means that we don't need the absolute value. We can just write this as log of bracket t over t plus 1. All right, so let's do that. We have limit t goes to infinity, log of t over t plus 1, minus log of 1/2. And let's take the limit. Actually, let's bring the limit inside the brackets. We get ln of the limit as t goes to infinity of t over t plus 1 minus log of 1/2. And dividing by the highest power, we're going to get ln of 1 minus ln of 1/2. ln of 1. Now, log of 1 is 0, so we get 0 minus bracket log 1 minus log 2. Log 1 is 0, the minus cancels out, minus times minus is plus. The answer is log 2. All right, so what we have is the limit as t goes to infinity, log t over t plus 1 plus log 2. We brought the log inside, we brought the limit inside. I'm going to do this again, even though we did it before, just to emphasize this. Limit t goes to infinity, t over t plus 1 plus log 2. That gives us ln 1 plus log 2. Log 1 is 0. The answer is log 2. So the integral from 1 to infinity, 1 over x squared plus x, 1 over x squared plus x, that's going to give us log 2. All right, here's some review of the log rules. Log of x over y is log x minus log y. So when you're dividing, basically you subtract. Log of 1 is 0. Log of e is 1. Well, we didn't use this one, but it's good to know it. And the limit as x goes to infinity of tan minus 1x is pi over 2. And tangent of pi over 2 goes to infinity. All right, thanks.